Hey everyone, Chadwick Strange here, head of product with your next Dap and Code updates. Want to walk everyone through a new feature that Scale Network will have in the upcoming release. This has been feedback by several customers to see, because Scale Network has a really unique architecture, is there a way that we can leverage some of the unique architecture and technology of Scale Network to provide Solidity developers a really good source of entropy for a random number generator? So the Scale Labs team thought about this and came up with a really nice feature. So it's an endpoint that provides a random number generator to Solidity developers. And I'll walk through sort of where this entropy comes from. So those who might not be aware, a scale chain is a set of 16 randomly selected nodes out of the Scale network. The Scale network currently being maybe 150 nodes currently, over 150 nodes. So your scale chain is sort of an independent subset selection of those nodes. And with any blockchain, anyone will be sending transactions to that blockchain. And so each of these 16 nodes collect these transactions and attempt to propose blocks. And so there's this broadcast phase of the consensus engine where, for example, one of the nodes, we'll call it node A, will send a proposed block to all the other nodes. And along with this proposed block will be hashes of the transaction. So there's a part where node B will receive this proposed block, and then it'll look up the hashes to be sure it has all the hashes for all the transactions. If not, it will request the actual transaction. If it has the hash of the transaction, it knows it has a match of the transaction that it's seen. So once it's received that proposed block and all the hashes, they currently have transactions that match all those transaction hashes. What then happens is that node B, who's received that block proposal, will send to node A threshold signature share back as a receipt saying, hey, I've got your proposed block, I've got all the transactions, we're good. And node A will continue to do this to send these proposed blocks to other nodes until it's received a supermajority signature shares from all the other nodes. So out of 16 nodes, that supermajority would be the threshold of 11. So node A proposes blocks until it's received 11 of these signature shares from the other 16 nodes. Once it does that, it basically sends a supermajority signature, including that proposed block, to the other nodes saying, hey, I've got a block, I have proof of receipt that the supermajority of nodes are in receipt of this block. So please, here's my supermajority signature share of the proposed block. Let's now move to a consensus round. And then once consensus round proceeds and all the nodes agree on the supermajority signature share of the proposed block, it then moves to a pre-commit phase to append that block and the containing transactions to the scale chain blockchain. Once it commits that block to the blockchain, the signature shares are aggregated, glued together, and then are used to sign that block to the chain. So when the signature share is glued together, it's really interesting because it's really difficult for any single party to influence the resulting signature. And this is a nice source of entropy. So how does these random number generator endpoint we've been discussing, or that I'm introducing, how does it pull from this? Well, it's pretty simple. We provided a precompile where the current block is presented to the precompile. And what happens in the precompile is it grabs the aggregated signatures from the current block. It performs a Blake3 hash to these aggregated signatures, and then it returns a resulting hex of this Blake3 hash through the endpoint. And so this provides the random number generator for the Solidity development. So what I'll walk through is a example scale chain I've already set up a scale chain on a machine. I've got it connected to my MetaMask. I'm going to move over here to my Remix environment. One second. Here we go. So I've got my Remix environment. I've got a contract here, and this is the basic example of the implementation. I have a contract with a get random function. It's using some assembly to access the precompile here at address 0x18. And it will be getting the current block and then returning a bytes 32, which is the Blake3, the hash of the Blake3 hash of the aggregated signatures of the current block. So let's see how this works. I'll compile it right here in the IDE, and then I will deploy. I'll move over to my injected Web3. Again, I'm connected to a custom scale chain network. I'll go ahead and deploy this, and then MetaMask pops up, asks me to confirm the deployment transaction, which I'll do. So I've deployed this contract to the scale chain. And so I'll access the get random function right here. I'll click this button, and then boom. It's walking through this, and then the decoded output here is our bytes 32. This is the hex of the Blake3 hash of the aggregated signatures of the current block. On each scale chain, blocks are produced fairly quickly, roughly on average 3 to 5 seconds currently on this SDK. So I'll hit it again, and then boom, I'm presented with another random number. Let me just double check that. Yep. So as a Solidity developer, you can use this precompile to access some assembly or using assembly to access the precompile to deliver for you a nice source of entropy for your development. Hope you've enjoyed this. If you have any questions, please don't hesitate to reach out to the community on the Scale Network Discord. Some of the Scale Labs teams will be at ETH Denver, so please stop by our booth. Happy to talk to you more, and everyone stay safe. Looking forward to seeing you all soon.